All right, let's do this. First thing, we've been graphing these, and you guys have been doing it. Many of you have been doing a great job graphing these on the polar grid, these points. Just remember, the points come in this form, R and then theta. All right, R is how many units away from the pole it is. Theta is where it is angle-wise on the graph. Today, here's what I'm going to do with you. We're going to take that polar coordinate, and we're going to make it into one of our old school XY coordinates and graph it. So we're going to take these polar coordinates, transform them into old school XY, and then as you guys can see on your papers, we're going to actually graph them on the rectangular grid, our old graph, XY axis. So that's our goal. All right, so first thing, part A, 2, 3 pi over 2. Graph it. Graph it. 2, 3 pi over 2. Looking at your assignments yesterday, most of you have this ability. Some of you guys are still struggling with it. Probably because you're not doing anything at home without your camera on and not taking any notes. That's my guess. I don't know how I could give you, and I'm going to rant right now. I don't know how I could give you the whole class period to do an assignment and you don't even turn it in by 8 o'clock that night. Basically just equals you're not doing squat at home. All right. Anyway, I'm done. 3 pi over 2. What are you guys multiplying by to figure out where this is? 6. Yep. Multiply it by 6. So we're really graphing 2, 18 pi over 12. Oh, thanks for gracing us with your appearance.
I got stuck behind two ladies.
Yeah, well, that's what happens. That's what happens when you go to your bro's house, during math time. I don't know what to tell you. All right, so 18 pi over 12. So figure out each one of these goes by 1 pi. So 18, I believe, is right down here. I am going to continue to draw the angle. You do not have to. You know that. I am going to continue to draw the angle to a certain point in this unit. So that's where I have to graph my point. It's 2. So I go 2 units away from the pole, so it should be right there. All good? All right, now what I want to show you today again is, all right, what would that polar point be in XY form? What would that polar point be in XY form? It is 2 formulas you guys do have to remember. I will not give it to you. Those 2 formulas are the first 2 up on top of your page in that box. To find the x coordinate, to turn into x, you do the following. R cosine your angle, theta. So R value times the cosine of whatever angle I put in there. All right, here we go. X equals, what's your R value here in the polar coordinate? What's in for R? 2. Cosine, what's your angle now? What was the angle that's there?
18 pi over 12.
Or 3 pi over 2. Yeah, either one. They're both the same, right, Caroline? So 3 pi over 2. Now that's in what? 3 pi over 2, is that a degree or radian? Radian, right? And I ask you guys that because when we calculate this value, your calculator's got to be in radians then too. All right, if that angle you plugged in is in radians, so does your calculator. So just a reminder, everyone go to your calc. You guys have a mode button right to the right of the second button. So I hit mode. Make sure radians is highlighted if it's not. Now it's all calculator. I'm not going to ask anything special here. Ready? 2 cosine. I'd get a fraction template out. 3, everyone knows where your pi button is, right above the caret. 3 pi over 2. 0. So the x coordinate for that one would be 0. X coordinate is 0. Now we're going to do the same thing to find the y coordinate, but instead of cosine, you use sine. All right, you guys can see that upstairs here. Those are the 2 formulas I'm using to find x and y. So y equals 2 sine 3 pi over 2. Same thing, type it in your, I'm just going to let you use your calculator. 2 sine 3 pi over 2. -2. So So y equals -2. So what's this coordinate, polar coordinate as a xy coordinate? 0,
0, negative.
-2. Yep, that's what it would be as an xy pair. And now graph it, and look where it ends up. Go ahead and graph 0, -2 on that rectangular grid I gave you. And compare it to the polar grid. Those points should be in the same spots, just on different kinds of graphs. Crazy. 0, -2 is the same point as 2, 3 pi over 2 on the polar. All we're going to do is convert it. That's it. Questions from you guys before we get to the next one? Yeah, go ahead. Next, shoot.
Can't you also do it with degrees too?
You could. Nick asked the question, can we do it with degrees? Yes. If you want to take 3 pi over 2, make it into degrees, just make sure that's in degree mode, your calculator. Yeah, I'm fine with that. Yep. If you want to put it in degrees instead, perfectly fine. Just make sure degrees is in your mode. Next up, part B. -8 pi over 3. What should I multiply there first before I graph on the polar? 4. Multiply by 4. So really -8, 4 pi over 12. Right? 4 pi over 12, making sure everything's at a 12. Let's see. 1, 2, 3, 4. So it's going to be here. Somebody remind me, negative R value? Go 180 on the opposite side. Don't graph on the angle I just drew in. We got to go 8 on the other side, directly 180 degrees on the opposite side. Let's see, where would that be? 1, 2, 3, right here, I think. Right there, on that line. Ooh, 8. We got to go 8 out. We haven't gone that far ever. So there it is. And you're ready to convert it with me now. Convert it into x and a y coordinate. So the x coordinate, r, -8. Cosine pi over 3. And again, like Nick said, if you want to turn that into degrees, that's fine. Just make sure it's in degrees in your mode. -4 for my x coordinate. Now we're going to start getting to decimals now, and I'll tell you what I need you to round to if that's the case. So to find the y coordinate, -8, now plug in sine pi over 3. I need you guys, if it is a decimal, just make it easy on everyone, round to the nearest tenth. All right, round to the nearest tenth. So -8 sine pi over 3. Just a reminder, got to remember these formulas for the quiz on Tuesday. I won't give them to you. -6.9. So there's your coordinate, -4, -6.9. And again, when you graph it, it should look in the same spot as your polar one was. One, two, three, 4. 1, 2, 3, 4, 5, 6, and a little more. About right there, probably. Yeah, pretty much that polar grid and that one look in the same spots. That's how you can check. Should be in the same area. Any questions from you guys at home here? Going? One more, and then I got some review stuff I need to go over with you. I'll just let you guys take it from here, and I'll start writing up my answers in a second. So graph it. convert it into XY, then graph the XY on the rectangular grid. People finish up, make sure we check our work, ask any questions before. This is the new stuff for today. Now I got to review stuff from back in November. That's going to help us out later on in this unit. Anything I can answer here in class or you guys at home? Anything converting it to XY? Pretty easy as long as we know those two formulas, right? Cosine goes with X, sine goes with Y. Questions, comments, any concerns going before we move on? All right, let's review now. Let's review, and this will help us on later on in the unit. Reference angles. Probably we don't even remember what those were. Here we go. Your angle. This is just Greek symbol beta. That's all this is right here. It's the same as theta, x, y, beta. 160. Can you guys help me graph one real quick? Can you graph 160 for me on the XY axis? So I could talk, review with you guys what a reference angle was. 160. I should be in quadrant 2. Okay, quadrant 2. There is a 160 degree angle going this way. All right, review of what a reference angle was. The reference angle is the acute angle, less than 90. The angle less than 90, that's formed by the x-axis and the terminal side of that angle we just graphed. Okay? The reference angle is the angle less than 90, always less than 90, formed by the x-axis, always the x, and that terminal side. So here you go. Here's my reference angle right there. Can you help me find the degree measure of it? Oh, is it? 170. 170.
It's 20.
Easy, yeah, I know. We know that. How do we get 20? Remember, this is 180 over here, right? So if I take 180 minus the angle I already know it is, 160, yep, that gives me a reference angle of 20. Yep. Always use 180 or 360 to determine your reference angle. Why? Somebody's going to know this. Why do I never want to use 90 or 270? What axis is 90 and 270 located on? The y-axis. And the reference angle is always on the x-axis. So I will never use 90 or 270 calculating these. Hey, 300. Let's graph it. And again, you don't need to graph these. I just think visually it's better for you guys if I teach it this way. The graphs aren't needed every time. So 300's in what quadrant? Yeah, you guys have been here 30 weeks already. Let's go. Quadrant 4. Reference angle. Again, not the y-axis. Everyone see that angle that's just been made with the x-axis and the terminal side? It's got to be less than 90. Here it is. There's your reference angle. How do I find that bad boy? Now I don't use 180. I'm going to use 360 minus 300. And that'll give me a 60-degree angle. Ready for a tough one now. What happens if I'm in radians? Radians.
You convert it.
Nah, you don't need to, Carol. You're better than that. But you are correct. I could convert it.
I got 30.
All right. I want you. Can you relax here?
Yes, sorry.
All right. Yep. I could convert it and see what it is in degrees, graph it, do it the same way. But remember, if your problem starts in radians, your final answer should be in radians. So my reference angle at the end, everyone's going to be in radians. Well, first, can you guys give me an idea what quadrant I'm in? -5 pi over 6. What do you want to do to it?
In the second.
Oh boy, I got first, I got second.
It'd be 10 pi over 12.
So I think that's what.
Oh, so you're basically staying in the unit and you're making it into polars, right? I like it. I was hoping you guys do that. So in class, we're like, hey, let's make this out of 12 now. So it's -10 pi over 12. And remember how the polar grid, it was 24 total? So what's going to be halfway? 12, right? But this is negative. So it's going where? Clockwise. So what quadrant should I be in now? Third. Yeah, this is going to be in the third quadrant. And that's all that matters. That's all that matters. I don't care how precise the angle is. All I know is this angle is going to be in the third quadrant. Woo, going that way. Clockwise, because it's negative. Again, how do I know it's in the third? There's 24 total on the polar grid. Halfway would be 12. So -10's got to be in the third quadrant if I'm going clockwise. All right, ready? Help me out now. How do I find that reference angle? Ready? Well, if I go all the way around, I know that's 180, but I'm in radians. So what is it? This is 180, right, in degrees, but I'm in radians in this problem. So what's 180 in radians? What have we been talking about? 180 in radians. Pi. So what can I do with the pi and the -5, well, it's just 5 pi over 6. What can I do with those two angles to find that reference angle? Look at the diagram. This is why I draw it. How can you find that smaller portion right there, that reference angle? What can I do with the pi and the 5 pi over 6?
Subtract them.
Subtract them, right? Hey, here's pi. I take this part away, you get the reference angle. So I'm going to do pi minus 5 pi over 6. Am I nervous that you guys are handling that? Absolutely not. This is what we've handled all unit. What's your common denominator? 6. What do you got to multiply pi by since it doesn't have a denominator of 6? 6? All right, big deal. No big deal. 6 pi minus 5 pi. And what's your final answer? Pi over 6. And Caroline, you said you got an answer of 30, right?
Yeah.
That's correct, Caroline. But remember, because my angle was in radians, I need your reference angle in radians.
Yeah, that's why I was confused.
That's 30, right? Pi over 6, that's 30 degrees in radians. All righty?
Okay, thanks.
Yep. Everyone else all right? All right, one more. 78 degrees. What's my reference angle if I have an angle of 78? Where is 78? First? Kids were just, heads were spinning in my second period class today of what the reference angle would have been. Any thoughts?
Would it just be 78?
Yeah, we use subtract 0, so wouldn't it still be 78?
I don't know. Just asking for thoughts.
That's not right then.
Okay. Anybody at home, thoughts? Kids in class have something here.
It would just be 78, right?
Stay 78. Correct. Right? Because I get ready. Reference angle. Got to be less than 90. Got to be on the x-axis and the terminal side. So if you guys, this is 78. If you guys are trying to find the angle next to it, which is 102, can't be a reference angle. It's bigger than 90. And if anybody's doing 90 minus 78, oh boy. Now you're using the y-axis. This is not a reference angle here. All right, it's got to be with the x. So yes, if an angle is in the first quadrant, it's its own reference angle. Good job. Questions on finding a reference angle? Last thing, let's go backwards. How about I give you the reference angle and quadrant? What was the original angle we started with? So I have a reference angle of 70 degrees in quadrant 2, everybody. Quadrant 2. Ready? So draw an angle that's formed by the x-axis and the terminal side in quadrant 2. There it is. There's your reference angle, 70. Everyone good? X-axis and a terminal side. Now what I want is start from the beginning. In the first quadrant, start from the beginning. What's that angle right now in the second quadrant? That's what I'm asking for. There's your reference angle of 70. What was your actual angle in the second? How can I find this one? Yep. This is 180. So if I take 180 minus the 70 degree reference angle, you get the rest, which is the one I'm trying to find. 110 degrees. Anything, questions from you guys? All right, now let's do radians now. Pi over 3. Okay, first thing, I'm in quadrant 3. I'm in quad 3. Draw a reference angle in quad 3 now. X-axis, terminal side. So here's pi over 3. There's a reference angle. Now, need your help. Starting from the beginning in quadrant 1, what's the angle in quadrant 3? Quadrant 3 now in radians. All right, this one's going to be a little tougher for us, I think. What's up, Anna? Okay, remember, yes, this is 180, but I'm in radians now, so this is pi. So I need pi, but now I don't want to subtract pi over 3. Because if you subtract it, what quadrant you end up in? 2. All right, so I'm going to add on the pi over 3. If you subtract pi over 3 in this case, does everyone see? You end up going backwards into quad 2. And I'm not even, you guys we should be fine adding these. Multiply the pi by 3. I get 3 pi plus pi. And then see what you can do with part C. Now you're in the 4th quadrant. So make a reference angle in the 4th quadrant. Put pi over 7 in there and figure out what the angle has to be in the 4th quadrant. Remember, the angle you're finding starts in the 1st quadrant, goes all the way around to the 4th. And you should not be using pi anymore. Good, guys, good, good. Should be taking 2 pi, 360, right? 2 pi now, and subtracting pi over 7. If you added it, you're going into quadrant 1 now. You're going past 360. If you add 2 pi and pi over 7, you're going into the 1st quadrant. We got to stay in the 4th, so subtract it. Common denominator of 7. Multiply 2 pi by 7 to get 14 pi minus pi. So your angle in the 4th quadrant to finish it off today, 13 pi over 7.
I'm confused on how when we know to add and subtract.
Okay, if you're in quadrant 3,
Yeah,
you got to add because you're going past 180.
right.
So I need to add it on. If you're in quadrant 2, you subtract because you got to go backwards. And then if you're in quadrant 4, I got to go backwards, so I subtract.
Okay.
So quadrant 3 is the only one where you got to add,
Okay.
if you want to remember that to make it easier. And then 1 is the same angle.
Okay.
Right? No adding and subtracting.
Isn't there an acronym?
A what?
An acronym? Wasn't there like the?
You're thinking all students take classes?
Oh, yeah.
That's just where sine, cosine,
Okay,
tangent.
yeah.
Nothing.
Never mind.
Don't get your confused, Anna. Don't get your classmates
Sorry.
crazy. Nothing to do with this. All right, assignment tomorrow, review Monday, quiz Tuesday. You guys know the deal now for the next 3 days. I will see you guys tomorrow. Behave, be safe.